This is section 1.6, part B. This is the second video for this section, so part 2. Looking at example 7. In the U.S., Department of Health and Human Services is now interested in smoking rates for U.S. teenagers. And they collected some data over various years. And it looks like we've already got this data graphed right here, and it looks like it's approximately linear, so we're going to make a linear model. Okay, so the first thing we want to do is consider the scattergram. Does a linear model appear to be appropriate? So that would be yes, it appears to be appropriate because the model has a downward decreasing trend. So yes, because the model has a steady decrease, indicating slope, decrease, indicating slope, so it looks like a linear model. Or it looks like a line. Okay. And the second part of this question is explain why linear regression would be the best way to find the equation of the model. And I know that I want to use regression anytime there are more than 2 data points or the data points don't line up exactly. So I'm going to use regression because there are more than 2 data points. Okay, so in part B, we're going to use our calculator to find that model. We want to work with years since 2000. So the first thing we're going to do is to list our t-values for each of these years. So if I want to list years since 2000, 2002 is going to get the t-value 2, then 3, then 4, then 5, 6, 7, and 8. Okay, now we're going to go to the calculator. And to go into the stat menu, we're going to click edit to enter the data. Up to the top of the list, hit clear, then enter to clear that list. Same thing, up, clear, enter. We're going to enter each of these values. So t values are 2, enter 3, 4, 5, 6, 7, and 8. And then for list 2, 13, 12.2, etc. Okay, get all our values in here, and I'm going to graph just to make sure that everything looks good. So in y equals, clear out any old equations, plot 1 is on, and then we're going to do a zoom stat. And oh man, I've got every single one of these. I've missed one, so it's a good thing I keep checking. Missed that third point right there, so let's edit it. It's supposed to be 11.9, not 1.9. There we go. Okay, so zoom stat again. Now it looks a lot better. Looks like it matches up with what I had already seen for the graph. Looks like a linear model. Okay, so now I'm going to find that model by going to stat, over to calculate, option 4 for linear regression, and down to calculate. All right, so here are my values. I need 3 places, so we're going to have negative 0.643, and our b value is going to be 14.243. Okay, so we're going to call this model P of t, and the slope is negative 0.643 t plus, we said 14.243. Okay, so that's my model. And we're going to use that model for the rest of this question. So in part C, use the regression model to find P of 18. It says by hand. By hand just means by using this equation. So negative 0.643 times 18 plus 14.243. And I am going to use my calculator to get that value. So negative 0.643 times 18 plus 14.243 gives us 2.669. And then I need to explain what it means in this situation. And I know that when I explain something like that, I have to talk about both values, the number I plugged in and the number I got out. So first, the number that I plugged in a t value, so that's going to be my year, and that's years since 2000, so that's going to be the year 2018. 2000 plus 18 is 2018. So my explanation is going to say that in 2018, the percentage of teens who have smoked will be 2.669%. Okay. And the last part of this question just asks us if this is an interpolation or an extrapolation. And since 2018 is beyond the data set, it's going to be an extrapolation. Okay, let's look at the next page to finish this question. Using the same regression model, find when P of t is equal to 6. So that model was negative 0.643t plus 14.243, and I want to find out when it's equal to 6. So I'm going to solve for the t value. So the first step would be to subtract the 14.234 from both sides, giving us negative 0.643t equals, and if you subtract 6 minus 14.243, 243, you would get negative 8.243. Then to solve for t, divide by negative 0.643. All right, so that should give us a t value of negative 8.243 divided by negative 0.643. Gives us a t value of 12.8195. So I can't run the t. I have to run the t. 12.82. Okay, and it's a t value, so I know that I need to add the starting year 2000 to get the year for that. That'd be in the year 2012. It's 12.8. It's late in the year, but it's still during the year 2012. Okay. So our explanation of what this means, we'll squeak it in over here on the side. In 2012, the percentage of teens who smoke is that value 6 that we plugged in for P of t. So the percentage of teens who smoked was 6%. Again, always in an explanation, make sure you mention both values, the value you plugged in and the value you got out. Okay. Part E, using the regression model again, find the P-intercept. Okay, so what I know about the P-intercept first is if I want to find P, this is the place where T, the other variable, is equal to 0. So what I'm looking for in part E here is P of 0, letting the t value, P of t, be equal to 0. That's going to be negative 0.643 times 0 plus 14.243. So the p value is, since 6.3 times 0 is 0, just the 14.243. Okay, so the two parts again, we have our 0, which is a t value, so plus the starting year. 0 plus 2000 is 2000, so this is going to be referencing that starting year, and this is the percent that we had. So this means, in short, that in 2000, 14.243% of teens smoked. Okay. Part F, using the model, find the t-intercept by hand. So the t-intercept is going to have p equal to 0. So my equation for p of t needs to be equal to 0. So I'm going to start with negative 0.643 t plus 14.243 equals 0, and we're going to solve for t. Because this side is empty, it makes most sense probably to add the 0.643 t to that side. Doesn't matter which side you move, but you just want to get the t and the number on opposite sides. I like to move that one just because it's going to make both numbers positive. So 14.243 equals 0.643t. If I divide both sides by 0.643, I'll get our value for t. Let's find out. 14.243 0.243 divided by 0.643 gives 22.15. So 22.15 is equal to t. And again, that's a t value, so I would want to add my starting year, which is 2000, to that to get the year 2022. So my explanation is going to be that in 2022, 0% of teens smoke. Okay, so again, we have to explain the value we got out, the 2022, and the value we plugged in, the percentage being 0, was the 0% of teens smoke in 2022. All right, part G, for what values of T will model breakdown occur? This is a good question to ask right after the two intercepts. Just to draw a quick sketch of what this line must look like. It has an intercept at the ordered pair 0, 14, so that would be up here at 0, 14.243. And it has another intercept down here at 22.15, 0. Okay, just a quick sketch. I draw this picture just because I know that this line does continue, and I want to talk about whether or not these make sense. So continuing down in this direction is going to get into the negative y values. So you're going to start talking about negative percentages, and that's not going to make sense. Okay. So we definitely know that this area down here is not going to make sense. We're not going to want values that cross the x-axis there. Okay. Back here for a little while, they're going to make sense because a negative time value is the year before 2000. So we make a prediction for 1990, 1995, etc. by going back this way. So right over here, it's okay for a little while. Eventually, if you go far enough back, maybe to negative 1,000 or something, you're talking about the year 1000, it might not make sense as much, but it's going to make sense for a while. So what I can say, which ones are not going to make sense for certain, are T values that are greater than 22.15, because these values immediately will cause negative percentages to be predicted. Okay, because these values predict that a negative percentage of teens smoke, and that's just not possible. Okay, when something is not possible, we know it's model breakdown. Okay, now that's the end of this section.